Every summer, my family and I travel across the world, 3,000 miles away, to the culturally diverse country of India. Now, India is a country infamous for its scorching heat and humidity. For me, the only relief from this heat is to drink plenty of water. Now, while in India, my parents always remind me to only drink boiled or bottled water. Because unlike here in America, where I can just turn on a tap and easily get clean, potable water, in India the water is often contaminated. So my parents have to make sure that the water we drink is safe. However, I soon realized that not everyone is fortunate enough to enjoy the clean water we did. Outside my grandparents' house in the busy streets of India, I saw people standing in long lines under the hot sun, filling buckets with water from a tap. I even saw children who looked the same age as me, filling up these clear plastic bottles with dirty water from streams on the roadside. Watching these kids forced to drink water that I felt was too dirty to touch changed my perspective on the world. This unacceptable social injustice compelled me to want to find a solution to our world's clean water problem. I wanted to know why these kids lacked water, a substance that is essential for life, and I learned that we are facing a global water crisis. Now, this may seem surprising, as 75% of our planet is covered in water, but only 2.5% of that is fresh water, and less than 1% of Earth's freshwater supply is available for human consumption. With rising populations, industrial development, and economic growth, our demand for clean water is increasing, yet our freshwater resources are rapidly depleting. According to the World Health Organization, 660 million people in our world lack access to a clean water source. Lack of access to clean water is a leading cause of death in children under the age of 5 in developing countries, and UNICEF estimates that 3,000 children die every day from a water-related disease. So after returning home one summer in 8th grade, I decided that I wanted to combine my passion for solving the global water crisis with my interest in science. So I decided that the best thing to do would be to convert my garage into a laboratory. Actually, at first, I converted my kitchen into a laboratory, but my parents didn't really approve and kicked me out. I also read a lot of journal papers on water-related research, and I learned that currently in developing countries, something called solar disinfection, or SODIS, is used to purify water. In SODIS, clear plastic bottles are filled with contaminated water and then exposed to sunlight for 6 to 8 hours. The UV radiation from the sun destroys the DNA of these harmful pathogens and decontaminates the water. Now, while SODIS is really easy to use and energy efficient, as it only uses solar energy, it's really slow, as it can take up to 2 days when it's cloudy. So in order to make the SODIS process faster, this new method called photocatalysis has recently been used. So what exactly is this photocatalysis? Let's break it down. Photo means from the sun, and a catalyst is something that speeds up a reaction. So what photocatalysis is doing is it's just speeding up the solar disinfection process. When sunlight comes in and strikes a photocatalyst like TiO2 or titanium dioxide, it creates these really reactive oxygen species like superoxides, hydrogen peroxide, and hydroxyl radicals. These reactive oxygen species are able to remove bacteria and organics and a whole lot of contaminants from drinking water. But unfortunately, there are several disadvantages to the way photocatalytic SODIS is currently deployed. See, what they do is they take the clear plastic bottles and they coat the inside with this photocatalytic coating. But photocatalysts like titanium dioxide are actually commonly used in sunscreens to block UV radiation. So when they're coated on the inside of these bottles, they're actually blocking some of the UV radiation and diminishing the efficiency of the process. Also, these photocatalytic coatings are not tightly bound to the plastic bottle, which means they wash off, and people end up drinking the catalyst. While TiO2 is safe and inert, it's really inefficient if you keep drinking the catalyst, because then you have to continue to replenish it even after a few uses. So my goal was to overcome the disadvantages of these current treatment methods and create a safe, sustainable, cost-effective, and eco-friendly method of purifying water. What started off as an 8th grade science fair project is now my photocatalytic composite for water purification. The composite combines titanium dioxide with cement. The cement-like composite can be formed into several different shapes, which results in an extremely versatile range of deployment methods. For example, you could create a rod that can easily be placed inside water bottles for individual use, or you could create a porous filter that can filter water for families. You can even coat the inside of an existing water tank to purify larger amounts of water for communities over a longer period of time. Now, over the course of this, my journey hasn't really been easy. I didn't have access to a sophisticated laboratory. I was 14 years old when I just started, but I didn't let my age deter me in my interest in pursuing scientific research and wanting to solve the global water crisis. See, water isn't just the universal solvent. Water is a universal human right. And for that reason, I'm continuing to work on this science fair project from 2012 to bring it from the laboratory into the real world. And this summer, I founded Catalyst for World Water, a social enterprise aimed at catalyzing solutions to the global water crisis. Alone, a single drop of water can't do much. But when many drops come together, they can sustain life on our planet. Just as water drops come together to form oceans, I believe that we all must come together when tackling this global problem. Thank you. Thank you.